Most software failures don't actually happen because the code is broken. They happen because real human beings are deeply unpredictable. Just think about it. When a page hangs, users don't just sit there. They retry, they spam the refresh button, they tap submit 3 or 4 times in a row. If your backend isn't designed to handle that chaotic behavior, a minor split second network hiccup can quickly cascade into double charges, duplicate payments, and hopefully corrupted data. So, to build system that can survive the real world, you have to design for these exact moments. And today we are going to break down one of the most vital concepts behind truly reliable APIs, de-duplication, or we say as idempotency. So, my name is Anubhav, and I'm senior software developer helping you break down complex topics into smaller, understandable chunks. So, let's get started. Have you ever clicked a payment button, waited a few seconds while nothing happened, and then clicked it again, and maybe even a third time out of frustration, only to check your bank app later and realize you were charged twice? Now, to a user, that just feels like a frustrating bug. But in backend engineering, this is actually one of the most notoriously difficult problem to solve. The issue isn't always that the request failed on the way to the server. Often the server processed the payment perfectly, but the response failed on its way back to the phone. It could be because of the weak internet, packet loss, or the user backgrounding the app. The client is left in the dark in these situations. Your server has no idea whether the user is retrying intentionally or because the network betrayed them. So, if your API isn't designed carefully, a minor network hiccup means you don't just get one order, instead, you get three. Distributed systems don't fail cleanly, they fail halfway. The database might succeed, but the network response drops, and suddenly you are stuck debugging duplicate money. Most people think this is an easy fix. Just check if the order already exists before creating a new one. But that's where it gets ugly. Imagine two identical requests arriving almost simultaneously at the same time. Request A checks the database and sees nothing. A millisecond later, before request A can finish writing to the database, request B checks and also sees nothing. But request get the green light. Both creates the record and you prevently absolutely nothing. Now, this is a well-known condition, and we have heard of it also. It's called a race condition, and it's exactly why modern APIs stopped trusting the timing and started trusting the identity. Now, this is where idempotency comes in. The core idea is surprisingly very simple. Instead of identifying operations by when they arrive, we identify them by a unique idempotency key generated by the client before the request is even sent. Something like this. Now, every single retry carries the exact same identity stamp. When a request reaches the server, the backend asks a simple question: have I already processed this key? If the answer is no, it executes the code, stores the result, and returns success. But if that exact same key appears again, the server doesn't execute a thing. It simply dips it into cache and hands back the original response. To the user, it feels like the retry worked flawlessly, but under the hood, you know it. Nothing actually ran twice. Retries stopped being dangerous and they became completely safe and fine for the user. So, of course, querying your primary database to check for duplicate keys on every single incoming request would eventually become incredibly slow and way too expensive. So, to scale this, production systems move this protection closer to memory using a redis. When a request arrives, redis creates a rapid temporary distributed lock. Think of it like hanging a work in progress sign on the door. If a duplicate request arrives with the same key while that sign is up, the system immediately rejects it or it waits. So once the heavy lifting is done, the final result is stored in the Redis. The lock expires and any future retries simply fetch the pre-computed response. It happens so fast the user never notices, but it saves millions of dollars in corrupted data. But even with the Redis, real-world systems are too messy. What happens if the system crashes halfway through an operation? The log still exists, the database was modified, but the response was never cached. Now, production grade architectures solve this by explicitly tracking request states like processing completed or failed processing. That way, a subsequent retry doesn't blindly start over or crash. It knows exactly where the previous attempt died and continues the recovery from there. So, at its core, backend engineering is less about writing code that works perfectly and more about designing systems that handle failures gracefully. Users will always retry, network will always fail, phone will disconnect, and server will timeout. So, idempotency is the reason modern APIs can survive that chaos. So, the next time you double click a payment button and only get charged once, you can thank an idempotency key for quietly saving the day. So if you like this video, hit that like button and share your thoughts in the comment section. And in the next one, we are uncovering another invisible architecture running the apps you use every day. And at last, don't forget to hit that subscribe button also and follow Dev Notes.